Hello and welcome back. Today we're having some more enrichment. One of my favorite topics, which of course is series. This is a 5-star question, and our objective is to find the sum to infinity of this particular series. Where do we start with this? First of all, it can be done a couple of different ways. If you want to have a go at it, pause the video and have a go at it. I'm just going to give a little clue. In fact, I've written up there this particular series, which is 1 plus 1 plus 1 over 2 factorial, which of course in sigma notation you can write like this, which of course we ought to know that this sums to E. So this is appropriate, I suppose, for further mathematicians, this particular topic. But even if you didn't know, if you take it for granted that this is E, you can still perhaps follow the workings that I'm going to do on this series. Okay, so if you're having a go, please do. If not, look how we're going to approach it. Okay, as I said, there's a couple of different ways. My favorite way of approaching this is as follows. It involves a lot of little tricks of re-indexing and writing things in slightly different ways, in order, manipulations if you want, in order to crack it. So the first thing that I'm going to do is I'm going to write it in standard sigma notation. So there's my sigma, and this quite clearly a general term, because of course we can write this as 1 cubed over 1 factorial. We can write it as a sum which runs from r is equal to 1 to infinity, and the general term of course is going to be r cubed over r factorial. So what do we do with something like this is the question. Okay, the obvious thing to do is perhaps cancel the r from the r cubed with the leading term of the factorial, of the r factorial, so this is going to become r minus 1 factorial, and I hope we can all see this a bit. So it's going to be from r is equal to 1, cancel an r, and of course the factorial now will start from r minus 1 factorial. So this is so far so good. What can we do next? If we look at putting r is equal to 1 in here now, this particular factorial will become 0 factorial, which is fine because of course 0 factorial is 1, but it makes sense perhaps to re-index the whole sigma starting from 0. So let me just write r is equal to 0 to infinity, and I'm going to claim, and we can check it of course afterwards, that this will now become r factorial over and r plus 1 all squared on the top. Let's check that these two expressions are exactly the same by checking perhaps the leading term. So if we're putting r is equal to 1 in here, the first term will be of course 1 squared over 0 factorial, and if you look at this one, when we're putting r is equal to 0, we're of course going to get 1 squared over 0 factorial. Basically all I've done is I mapped, it's a little bit of a sloppy way of writing this, I mapped r into r plus 1, you can think of it as. So the r became r plus 1 minus 1 gives me that, and of course this became this. It's exactly the same thing, just running from it, the dummy variable is running now from 0. And of course, what do I gain by doing that? First of all, r is equal to 0 is nicer because of this, really, of this little clue. And also, by having this now, I can actually split it into 3 separate sigmas using the linearity of the sigma notation. I'm going to do this step in one. So I'm going to expand the numerator, split it, and have 3 separate sigmas. I'm going to write here perhaps the numerator, so that's r squared plus 2r plus 1 over r factorial, so we can all see what I'm doing there with the sigmas. Let me move that cable out of the way. So this will now become sigma, r is equal to 0 to infinity. The first term will be r squared over r factorial, and then we're going to have plus the 2, which is constant. I'm going to move it outside the sigma operator. So we're going to have from r is equal to 0 again to infinity, r over r factorial. And lastly, we're going to have 1 over r factorial, which is beautiful. And can you see why I say it is beautiful? It's because of something I've written on the board up there. This, in fact, is E. So we're going to have these two sigma terms and plus E on the next line perhaps. So let me just write this plus E for this particular sigma. Is there anything else now that we see on those two sums, something of interest? I claim there is, if you look carefully. If you look when I put r is equal to 0, the factorials are fine because of course 0 factorial is 1. But if you look at both the numerators, r squared, when I put r is equal to 0, 0 squared, and this one 0. So in fact the first term from this sigma and this sigma is 0. So we lose nothing by starting the summation from r is equal to 1, since the first term is of course 0. It's exactly the same. So I'm going to say I'm not doing anything. All I've done is I'm changing the start of the summations for those two. Infinity from r is equal to 1 and r over r factorial. And this is now, I need to take a deep breath and see, okay, have I made progress? What is going on? And the thing to notice is, if we look at the very beginning, we started with something which looked like this, r cubed over r factorial, starting from r is equal to 1. And now we got two sigmas which are practically of the same family, only simpler because of course the r cubed has reduced to r squared and to r, which is even simpler, and both start from 1. So what does that tell me? Well, it tells me I can actually repeat the process. Whatever I've done up there, I can actually do it again and hopefully get somewhere. So for example, now I can cancel again an r with the r factorial and this r with the leading term of the r factorial. So let's do that bit by bit and see how this will simplify. So let's create some room. I'm going to wrap this line off as well. And I think we're getting, this is definitely going to work. So we're going to cancel, as I said, the r with the r factorial there. Still having it from r is equal to 1 to infinity, of course. So that's going to become r over r minus 1 factorial. And on the second term, we've got the 2 at the front. From r is equal to 1 to infinity. And when we cancel this 1, sorry, not this one, when we cancel the r into a 1 rather, we're getting something which looks like this, plus of course the lone e at the very end. Is that good? I think it is good. And the next term that we need to concentrate on is this particular one. Let's look at what happens when we're putting r is equal to 1 in there. We're getting, this starts with 1 over 0 factorial. When we're putting r is equal to 2, 1 over 1 factorial. And when we're putting r is equal to 3, we're going to get 1 over 2 factorial. I claim this is in fact your e, and the reason we don't recognize it there is because it starts from r is equal to 1. We can re-index again. In fact, both of the sigmas, so it's pretty much identical steps. So I'm going to start both summations again from 0, but of course this will change these quantities a little bit. This will go r factorial, and the top will become r plus 1. Okay, just checking that it's exactly the same thing. This will go 1. Now it also becomes 1 because of course 0 plus 1 is 1. And when we're putting 1, this is 0 factorial and this is still 0 factorial. And similarly for the other term. We've done this already twice, so it's pretty much the same technique. So this will become 1 over r factorial plus of course e. And if we look up here, I'll put it in red. This particular summation, which of course is this, is in fact e. So that's another e here, but of course we've got times 2 at the front. So altogether, we're going to have this 2 bits added together. It's going to be 2e plus another e equal to 3e. And we can continue from there. So let's write on the top again, so it's easier to see, the stage we're in at the moment, which is of course this sigma from r is equal to 0 to infinity of this quantity. Shall I write it again exactly like that, just merely to add plus 3e at the end? I guess we can do more than that. We can actually split the fraction. So I'm going to have r divided by r factorial plus another sigma, again running from 0 to infinity, 1 over r factorial plus, of course, so this 2 sums is this, and of course I need to add 3 lots of e at the very end. Anything else interesting there? Yes, well, I got another e appearing there. This particular sigma running from r is equal to 0 to infinity is, of course, by definition e. It's up there. So let's do a couple of things at once. So I'm going to write in the next line, of course, e plus 3e, 4e. But the question is, what do I do with this particular expression there? Well, if we notice there, you see that r is equal to 0. When I put it in, the first term is in fact 0. It's going to be 0 over 0 factorial, which is 0 over 1, which is 0. So I can start it again from r is equal to 1. Okay, and lose nothing by doing so. So it's going to be r over r factorial plus e plus 3e, because that's another e, of course, is going to be 4e. What do I do next in there? Well, quite clearly, I'm going to cancel one of the r's. So r from the top and from the bottom, r is equal to 1 to infinity. It's going to give me 1 over r minus 1 factorial, cancelling again the leading term of the factorial, plus 4e. I think we've done this, and I wish my board was big enough to actually see that this particular quantity, what it is, rather than redoing it every time for the obvious. But if you look again, when I put r is equal to 1 in there, okay, this becomes 0 factorial. So I may re-index it to start from 0. So from r is equal to 0 to infinity, and when I re-index it, the r minus 1 will become, of course, r factorial. You can check that these two are having exactly the same terms, plus, of course, 4e. And, of course, the sigma at the front is another e, and therefore our answer to this particular sum is 5e. Isn't that beautiful? Who's laughing now?